Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. In this video, I will present about work and energy. Before starting the presentation, allow me to introduce myself. My name is Citra Anisa Fitri from Department of Physics, Universitas Negeri Semarang. Okay, here there are 4 points of discussion. The first is work, the second is energy, and the third is work relationship with energy, and for the last is mechanical energy conservation law. Okay, next, from the first is work. But before that, I have a question. Have you ever pushed a car that was breaking down, even though we've done a various kind of force so that the car can move and change places, but sometimes the car still remains stationary? In physics, this phenomenon is considered not to do work. Why? Okay. In physics, work is defined as a force that causes a displacement of an object. As in the PPT, a child pushes a block until it moves. So that in the previous car incident, we can say that we didn't do work or work is equal to 0 because the car doesn't move. Okay, now how to determine the work in physics? On the first, we will determine the work if the force acting in the same direction as the displacement. For example, when we push a trolley in a supermarket, the force exerted by our hand is parallel and in the same direction as the displacement of a trolley. For this event, the work is equal to F times delta x or displacement. Okay, next, for the second is if the force acting at an angle with the direction of displacement. For example, when we move a pile of books with a toy car on the floor, the force exerted by our hand when pulling a toy car will form an angle to the floor. So, the work is equal to F times cos theta times delta x, where theta is an angle between the direction of the force and the direction of the displacement. Okay, next is if the direction of the force acting is perpendicular to the displacement. For example, a porter lifts an object from the floor and moves it into a place horizontally. Then, the force acted will be perpendicular to the direction of displacement. In this case, the amount of work is equal to F times cos theta times delta x. And because between the force and the direction of displacement from an angle of 90 degrees and cos 90 degrees is 0, then the work is equal to 0. Okay, now, what if the direction of the force acting is opposite to the direction of displacement? For example, when we use a treadmill, the force exerted by the sole of our feet rubs against the track of the treadmill. For this case, we can still use the same formula, namely, work is equal to F times cos theta times delta x, where theta is 180 degrees and cos 180 degrees is minus 1, so work is minus F times delta x. Okay, our next discussion is energy. Energy is the ability to do work, so work and energy are related. This time we will discuss about potential energy, kinetic energy, and a combination of both or mechanical energy. For the first is potential energy. Potential energy is energy that arises due to the position of an object with respect to a reference point. For example, the position of a climber when climbing a hill, or the position of coconut on a tree. Potential energy is divided into two. The first is gravitational potential energy, namely potential energy that arises due to the gravitational force. For example, a ball that is bounced up will return to the ground. The gravitational potential energy is written by the equation EP is equal to m times g times h. And next one, the second is the potential energy of the spring. Spring potential energy is the potential energy stored due to the change in the shape of the spring, either because it is pulled or pushed. The potential energy of a spring is written by the formula EP is equal to a half times K times delta X squared. Okay, next is kinetic energy. Kinetic energy is the energy an object has due to its motion. The faster an object is moving, the more kinetic energy it has. For example, someone who is walking or running, and a vehicle that is moving or speeding. Kinetic energy is written by the formula EK is equal to a half times m times v squared. Okay, next one, the third is mechanical energy. Mechanical energy is energy that an object has due to its character motion. Mechanical energy is kinetic energy plus potential energy. For example, is the billiard ball. When playing billiard, the mechanical energy from the stick is transferred to the billiard ball. This causes the billiard ball to move and travel some distance before it stops. Mechanical energy is written by the formula Em is equal to a half times m times v squared plus m times g times h. Okay, now let's discuss about the relationship between work and energy. The first is relationship between work and kinetic energy. Work equals the change in kinetic energy. So, work is equal to EK2 minus EK1. Work is equal to a half times m times v2 square minus v1 square. Okay, for the second is the relationship between work and potential energy. Work equals the change in potential energy. So, work is equal to EP1 minus EP2. Work is equal to m times g times h1 minus h2. Okay, finally, we discussed about the law of conservation of mechanical energy. If there are no external forces acting on the system, the sum of the potential energy and kinetic energy at each point is constant. So, EM1 is equal to EM2. So, EK1 plus EP1 is equal to EK2 plus EP2. So, a half times m times v1 square plus m times g times h1 is equal to a half times m times v2 square plus m times g times h2. Okay, now I have a question. A block of mass 10 kg is on a smooth floor. The block is pulled with a force of 25 Newton and forms an angle of 37 degrees with the horizontal direction. After moving 2 meters to the right, how much work is there on the block? Okay, from the equation, we know that M is 10 kg and F is 25 Newton and theta is 37 degrees and S or displacement is 2 meters. Now, how much work is there on the block? Okay, so the answer is work is equal to F times S times cos theta. So, work is equal to 25 times 2 times cos 37. So, we can find the answer is work is equal to 40 joule. Okay, that's all for my presentation. More or less, I apologize. I hope that what I say in this video will add to our knowledge. And thank you very much. Assalamualaikum warahmatullahi wabarakatuh.